Hopefully by now it's clear that we can only combine radical expressions in very specific circumstances. Most of the time we cannot combine them. Okay? Well, there will be occasions where we can combine them, but it doesn't look like we can because they're in disguise. Let's look at this example to begin with, and then we'll see an example like that. Can we simplify this thing? 4 plus 2 square roots of 18. Well, it's clear that we cannot combine them. This is not even a radical expression, and this one is. There's no putting those together. We certainly are not going to do 4 plus 2 makes 6, because this 2 is attached through multiplication to the square root of 18, and the 4 is not. However, we can do a little simplifying because the square root of 18 is not in simplified form. So we have to simplify that radical. Remember how we do this. If we factor 18, it is 3 times 6. 6 is 3 times 2. So 18 is 3 squared times 2. That means that this expression, 4 plus 2 square roots of 18, is equal to 4 plus 2 square roots of 3 squared times 2. We can take the square root of the 3 squared because the index 2 divides evenly into the exponent 2 here on the 3. And so we divide the exponent by the index. 4 plus 2 is the same. This comes out as a 3 to the first power. This 2 has to stay inside the square root because it is only to the first power. And then 2 times 3 makes 6, so we get 4 plus 6 square roots of 2. We still can't combine them because one's a radical expression and one isn't, but we were able to simplify it a little bit more. That means that we'll also find radical expressions that we can combine, but we won't be able to tell until we simplify them first. Let's look at this example. 14 square roots of 3 minus 4 square roots of 12. They're both radical expressions. Doesn't look like we can combine them, though, because the radicands are different, 3 and 12. Well, that may be and it may not be. We have to put these in simplified form before we can tell whether we can combine them. Okay? This is already simplified. There's nothing more we can take out of the square root of 3. But the square root of 12, there is more we can do. Square root of 12 is equal to the square root of 2 squared times 3, which is 2 times the square root of 3. So that means what we get here is 14 square roots of 3 minus 4 times 2 square roots of 3. Or 14 square roots of 3 minus 8 square roots of 3. And lo and behold, these are like radicals. They are both square root of 3. Same index, the square root, same radicand, 3. So we subtract their rational coefficients. 14 from minus 8 is going to give us 6 square roots of 3. This is also true when the index is higher. We have 2 times the 4th root of 32 minus 7 times the 4th root of 162. Again, it doesn't look like they can be combined, but we need to simplify these radicals to tell. Well, 32, well, let's do them all at once. 32 is 2 to the 5th power, and 162 is 3 to the 4th power times 2. Okay? Well, we take out a 2 to the 4th power, one of the 2's gets left behind. Here, take out the 3 to the 4th power. Again, the 2 gets left behind. And just as in the previous example, we see we end up with the fourth root of 2 on both of these, so we will be able to combine them after all. 4 times the fourth root of 2 minus 21 times the fourth root of 2. 4 minus 21, negative 17 times the fourth root of 2. It's important that you don't lose your index along the way and accidentally turn it into a square root. That would, of course, change the meaning of the problem. Here's a final example, and this one involves variables. Square root of 98x to the 5th plus the 5th root of 64x to the 6th. Well, again, we simplify each one first. So 98 is 7 squared times 2, and x to the 5th, we take out the square factor, which is x to the 4th, because it's the square root. Here, 64 is 2 to the 6th power, okay? And x to the 6th, well, we can write 2 to the 6th power as 2 to the 5th power times 2. X to the 6th, we can take out that x to the 5th, I almost forgot my 5th root, times an x. So here when we take the square root, those with exponents that are even are going to come out. Notice the exponents divide by 2, the index. This 2 and x stay inside. Here, these with exponent divisible by 5 come out because the index is 5. Again, the exponents divide by 5. This 2 and this x stay inside. Okay? And remember, it's the 5th root. Now, we've simplified each radical expression. Can we combine them? Well, in this case, the answer is no, we can't. The radicands are the same, 2x, but the indices are different. One's a 5, one's a 2. So sometimes, even after we simplify each radical expression, we find that we still can't combine them because they are not like radicals. So this would be the simplified form of the expression we started with. Now, one last note. What if we had 7x squared times the square root of 2x plus 2x times the square root of 2x instead of the 5th root of 2x? In that case, they are like radicals. Same index, same radicand. So we can combine them. Well, that means we add what's in front of the radical piece of it. So 7x squared plus 2x. However, 7x squared and 2x are not like terms. Based on the discussion we had at the beginning, they have different exponents, x squared versus x. So the best we can do is to say, well, that's 7x squared plus 2x, and that whole expression is being multiplied by this square root of 2x. That is how we would combine those. We can get it down to one radical expression, but the so-called coefficient consists of a polynomial involving 2 terms. The moral of all this is that we have to have like radicals to combine them. But we can't always tell if the radicals are like until we simplify first. So a lot of this just comes back to simplifying radicals.